Welcome to qnawire.
Hey there, this is Josh. Okay, we got a problem where we want to find out what the magnetic field is for this system and then the kinetic energy. Okay, so starting from equation 44.7, we can make a few notes. First off being this. Let's write down, first off, for A, we want to know what B is. And for part B, I want to know what my maximum kinetic energy is. Okay, let's start with part A. So first off, I know that omega is equal to QB over M. And additionally, I know that omega is equal to 2 pi f, or how many circles and radians I cover per second. Okay. Now let's set these equal to each other. 2 pi f is equal to QB over M. All right. And let's go ahead and look at one more thing here. I can solve this for B, and I get that B is equal to 2 pi f m over q. And I'm just going to use the absolute value of q for now. Okay. Now, if we plug all this in, my mass is equal to 3.344 times 10 to the minus 27 kilograms for a deuteron. And Q is fundamental charge. Typically, it's 1.602. In many calculations, you can generally just do it as 1.6 times 10 to the minus 19 coulombs. Coulombs is charge, just as kilogram is mass. And I'm going to plug all my parameters in. The frequency is given in the problem statement. When you do this, you plug it all in, you get that the magnetic field is equal to 1.18 Tesla. Okay. That is the first part. Let's go ahead and look at the second part, part B. All right. So equation 44.8 tells me that K max is equal to Q squared B squared R squared divided by 2M. All right. We have a value for Q. We have a value for B. R we have a value for. Let's make sure it's in meters. And divided by 2 mass, which we have mass up here. So we have everything else we need. We're going to plug it in. We're going to get that it is equal to 5.471 times 10 to the minus 13 joules. Okay, joules is fine if we want to put this into electron volts. 1 joule is equal to 6.24 times 10 to the 18 EV. So this is equal to this in joules, or 3.42 mega electron volt. Okay. Now, if I want to solve this for velocity, I would be interested in working in joules. Okay. So let's clear some space here. You can simply just rewind for some of this other data. Kmax equals 1/2 mv squared. If I rearrange this, I get that V is equal to 2 times Kmax divided by M square root. Okay. Now we knew that our K max was equal to 5.471 times 10 to the minus 13 joules. So we're going to work in joules and kilograms, and that will give us a value in meters per second. Okay. V is equal to the square root of 2 times K max, which is 5.471 times 10 to the minus 13 joules, divided by my mass, which I'll leave as m. It's written right above us. It's written right here. We have mass here, and we have my energy given here. Okay. When I calculate this, I get that this is 1.8 times 10 to the 7th meters per second. Remember, if you need to look back at how we calculated for the kinetic energy, just rewind just a bit. Okay, thanks.